Hello, my name is Casimir Smith and I am an undergraduate student at Rice University. I am presenting my paper on haptic training using cutaneous, spatially separated assistance. One strong advantage of haptic devices is their ability to train people in a virtual environment. Within this simulated environment, haptic devices apply two kinds of forces: task forces, which represent the physics of the environment, and guidance forces, which give users information on how to complete their goal. However, when task and guidance forces are relayed through the same device, users can become confused on how to interpret any given force. One way to avoid this problem is through cutaneous, spatially separated assistance, which places a small, low-power device elsewhere on the body to apply forces to the skin. The user completes the task through a kinesthetic device, while the cutaneous device stretches the skin to transmit guidance forces. This experiment asks whether cutaneous SSA can be used for complex feedback training. We chose the virtual task of balancing an inverted pendulum. The subject controls the pendulum and feels the reaction torque through a coupling between the kinesthetic task device and the pendulum joint. The system is non-deterministic and changes based on user input. Because of this, it requires guidance based on a feedback control loop, which mirrors complex real-world tasks. To provide guidance forces, a controller computes the optimal torque to stabilize the pendulum in real time. This torque is then rendered on the user's arm by the cuff band, guiding them to complete the task optimally. 3 difficulties are achieved by modulating the length of the second arm. We devised an experiment to test this training method. Within each experimental block, subjects complete an equal number of easy, medium, and hard trials. One test condition alternates between blocks where subjects receive cuff haptic guidance and blocks where they do not. The other condition trains without cutaneous guidance at all. Subject performance was measured by how long they maintained pendulum balance. When guidance is active, subjects gain a statistically significant increase and achieve better final performance across all 3 difficulties. However, when tested again without guidance, there is no statistical difference between the 2 test conditions. In conclusion, active cutaneous guidance can boost performance in complex virtual tasks. This experiment proves the efficacy of cutaneous, spatially separated assistance for tasks which require feedback control, expanding its use to a much wider range of potential tasks.